10 Advanced End of Term 1 Revision, Lesson 2.3, Motion in Electromagnetic Fields. 2.3.1, Applying the relationship between the magnetic force on a charge moving in a magnetic field. So basically, there's no force if the particle was at rest, or if it is moving, if the charge is moving parallel to the magnetic field. This means if the magnetic field is along the horizontal, the velocity was also parallel to it. In this case, the force equals to 0. You have an electron moved with a speed 310 to the power of 4 meters per second parallel to a uniform magnetic field. So in this case, the angle is 0, so there is no force. The force is 0. Question 2, you have a stationary. This means at rest, not moving. This means that the velocity equals to 0. Positive charge Q is located in a magnetic field. So basically, which of the following is true regarding the direction of the magnetic force? It will experience no force because there is no velocity. This one equals to 0. So there's no magnetic force. And also here it is 0. However, you have a proton that passes into a region of magnetic field of strength 5 millitesla, yani 10 to the power of negative 3, as shown in the figure with a velocity of 100 meters per second. Calculate the force experienced by the proton given that it is doing an angle of 30. So F equals to Q V B sine of the angle. However, Q is always of the proton or of an electron is the elementary charge, 1.6 10 to the power of negative 19 coulombs. However, also the velocity is here 100. The magnetic field is 5 10 to the power of negative 3. No need to put the unit inside. Times sine of 30. The total, the answer is 4 10 to the power negative 20. The unit of the force is in Newton. A very similar question. You have an electron enters the magnetic field perpendicularly. That's okay. So this means at an angle equals to 90 degrees at a speed given. And it experiences a force of this much. What's the magnitude of the magnetic field given the relationship between the magnetic force done on a charge entering a magnetic field? Q VB sine of theta. So here you have 1 10 to the power of negative 13. The elementary charge, I don't put it negative in absolute value. The velocity is 5 10 to the power of 5 b, I don't know, multiplied by sine of 90 because it enters the region at perpendicularly. So the magnetic field in Tesla is equal to 1.3. Later, find the direction of the force in a current. For example, here I have my current is downward. The magnetic field is not given very explicitly. However, I know that it goes out of the north into the south by applying the right hand rule, pointing my finger down, and so it will be out of the page. The force is out of the page. So F is like a dot. Also here, I need to complete the direction of the force. I need to find the force. So the magnetic field is to the right, the current is out, so F here by applying the right hand rule is upward. Also here I is downward, so I'm requested to find the force, meaning that the cross is for the magnetic field. Here is it is to the right, and finally I know the current, I need to find the force, so basically whatever is dot here, it is for the magnetic field. Applying my third right hand rule, the force will be upwards. 2.3.3, applying determining the magnitude of the force on a current carrying wire in a magnetic field. We have a wire of length 50 centimeter carrying a current of 10 amps, positioned perpendicularly, the angle is 90, to a uniform magnetic field. Experiences a force of 3 Newton. What's the magnetic field strength on this wire? So F equals to I B L sine of the angle. 3 equals to 10 by B. However, here I don't forget to convert. So it is 50 10 to the power negative 2 by sine of 90. So B is in Tesla 0.6 Tesla. We have a straight wire that is 25 centimeters long. Again, that's the length, carrying a current perpendicular to a magnetic field in Tesla 5 Tesla, and experiences a force of 8 10 to the power of negative 3. What is the current I? So again, so the force I B L sine theta, so 8 10 to the power of negative 3 equals to, I don't know, I keep it as an unknown, times 5 Tesla. I don't put the unit inside. The length is 25 by 10 to the power of negative 2, and perpendicularly sine of 90. Make sure that your calculators are in degree, not in radian. So I equals to 6.4 10 to the power of negative 3 amps. Finally, recall that for parallel current carrying wires, the force is attractive when the currents flowing are in the same direction, and vice versa, it is repulsive when they are moving in opposite directions. So we have two long parallel conductors carrying current lie in horizontal plane. The two conductors, they repel one the other. So if they are experiencing a repulsion forces, this means, so that's the force, the repulsive force, this means that they are moving in opposite directions. Oppositely, here we have two wires that I can see they are moving in the same direction. The question is the force between the wires attractive or repulsive? So basically it is attractive. Wire P will move downward and wire Q will move upward. So this is the shape later on of the two wires. Thank you.